this video, we explain how two cyclic tasks with different intervals and priorities execute code. You'll see how the Execution and Synchronization Manager, the ESM, is configured for that purpose by PLCnext Engineer. A code example will show how the Global Data Space, the GDS, provides data consistency between programs that are executed by different tasks. The timing diagram shows that the system tick is set to 1 millisecond. The fast task provides a computation every 5 milliseconds, the slow task every 12 milliseconds. The programs fast PG and slow PG are assigned to the respective tasks. They are executed in the context of the tasks. If both tasks require computation time simultaneously, the fast task will be executed with higher priority. If necessary, the slow task execution will be interrupted. We open the task structure of a tutorial project. In ESM1, there are the tasks T50 milliseconds and T300 milliseconds. Scrolling to the right, you see the intervals and priorities of the tasks. Here, you can open the programs FastPG and SlowPG by double-clicking. The programs invert Boolean outputs of the digital I/O module in the Alive worksheet. In SlowPG, the analog value of the potentiometer is copied to the bar graph. How the programs are assigned to the tasks we see in the PLCnext Engineer editor in the Program Type column. The FastPG program is executed in the context of the T50 milliseconds task and the SlowPG in the context of the T300 milliseconds task. Now let's see how the data is exchanged between programs that are executed in different tasks. The FastPG increments a global variable read by the SlowPG. You see that there could be data inconsistency if the SlowPG on a lower priority task is interrupted by FastPG on a higher priority task. This will happen if the function block utilizes too much computation time. Then SlowPG will get different values of the global variable in the same cycle. With data interchange via the global data space, the GDS, this can't happen. Here the FastPG writes the value of the global variable as output into the GDS, and SlowPG reads the value as import out of the GDS. Let's see how that works in debug mode of PLCnext Engineer. We see the FastPG program, and here is the worksheet just count. Here the global variable is incremented, and the value is written into the GDS as output. The evaluation worksheet is open in the SlowPG program. First, the value of the global variables and the import variables from the GDS are saved for the current cycle. Then the function block, fbTakeTime, is called with the converted value of the analog input module. The higher the value is, the more computation time the block requires when the first input bit of the digital I/O module is set. This can lead to the processing being interrupted by the FastPG. This further increments the global variable. This can be seen in line 10 if the value of the global variable is now greater than the value stored at the beginning. Thus the difference is greater than 0. We now set the activation bit and increase the analog value. If the value of the variable UD loop is greater than 950, SlowPG is interrupted during the execution of fbTakeTime. This makes UD counterdiff in line 10 greater than 0. Just as the value of the global variable was analyzed during access in the SlowPG, the data exchange via the GDS in line 13 is also analyzed. This shows that the import variable remains constant over the entire cycle. So that's how the ESM and the GDS work together to provide data consistency between programs that are executed by different tasks.